Hi, we are Build4U. This is our P3 presentation.
So here we have the bills of materials, and it's just a couple of materials that we will be using for our physical model, which includes wood, spray paint, acrylic paint, cardboard, etc. And it also includes the Revit software since we are creating a Revit model.
We have also the tools and equipment, which also correlate with the bills of materials since it's a physical model. It includes like the measuring tape and a ruler, anything like that. And we also have the cost, so it cost effective to show it's cost effective.
So what is the knowledge needed? We need digital floor planning, architecture rendering, site rendering, and architecture 3D modeling. We need all of these things to be able to design our model in Revit. We also need multi-view drawings so we can create our subsystems, and mathematics and critical thinking so we can be able to test our subsystems and our prototype at the end.
So we have 4 subsystems we're testing, which are the recreation room, the engineering room, the science room, and the computer/study room. And as you can see, there's lines, which is like the flow of the layout. We also have everything labeled, and there's dimensions of how big the room is.
So right here's the 3D model of the early college. We are planning to make as one. As we see here, it's 3 floors. And right here is our individual floor plans. This right here is the first floor plan. Right here is all the administrative stuff. So right here is the principal office, the room, and the council room. And right here is the dining room where all the students will come and eat and all that stuff. Right here is the engineering classrooms. Right here will be all the storage places for them to store their stuff. Right here is a maker space as well as a little garage door for easy transport. We decided to have the engineering/science classrooms on the first floor, all because it'd be easy to all transport all the equipment there. For instance, the maker space would be constant refill for all the equipment used. And right here's all the stairs and bathrooms can be useful. And on the second floor, right here will be the computer/study rooms. Yes, that's where all the students would go to do the projects, work on engineering, all that stuff. Right here will be the virtual learning classrooms. Since due to COVID, most of the schools will be concerned about all the teaching stuff and how the students will learn. So we have a designated area for that. Right here is the English, mathematics, and history class. Right here will be more focused on all those stuff. So that's it for the second floor. And for the third floor right here, will be all the presentation room and virtual learning classrooms, as well as a little lounge area for the students to relax, take a break. Right here is still GD classrooms for the English and history and all that stuff.
So for our specifications, we updated them so it can help us, first of all, guide us to help us build our prototype as well as help us test it. So we included new things such as health services, resource center, and computer room/STEM classrooms. And we needed all of those specifications because they helped us give us input on what we needed in our prototype and how to build it, as well as we can use them to base our testing off.
For our testing standards, we cut it into 4 sections. The first one is building system evaluation. Then we have the building evaluation as a whole, and then we have the aesthetics and then the safety. The first section consists of the elevator and the stairs. The second section is the roofing and the interior finishes such as the door frames, the flooring, the material cabinets. Then we have the aesthetics, which is the way the school looks, and then safety is the CMS safety standards, and then the coronavirus standards.
And brainstorming for our testing documentation, obviously because we don't have a real life school that we can test, most of our testing has to be theoretical. So the first thing would be simulations, which would consist of what if situations, and we would think about it in the sense of if students would walk into a classroom, how would that work out and how would they be able to walk safely and have enough space in between them. Next would be professional feedback. So that would be us going to professionals and asking them, basically getting feedback on our prototype in sections and seeing would this work if this was in real life. And lastly, we are using our code books such as the CMS Architectural Design Code Book, the DCS, which is the Disability Laws, and commercial architecture codes and COVID-19 codes.
So for our for the testing table, the first column consists of like the types of rooms we're testing and the title of the testing. And then the first row is the type and how we're gonna test it, and then the code that supports the testing, the degree of accuracy, if it follows the standards, and then we have the description.
So here are some more pictures of the table, and through our testing, we made sure our testing is accurate as much as possible since it is difficult to test the building. But in the process, we use codes and expert feedback to support it.
Oh, this is our expert input. These are all the inputs our mentors gave us about the testing standards that we've chosen. Um, our UNCC mentor talked about, it's really difficult to test a design. So she mainly talked about, it's always good to get a fresh eye, third opinions on all this matter. And as for Ms. Bullwhite, she always talked about, designs always talks about the codes. If you don't have the right codes with the design, it's not plausible to have that to have the design come to life.
And corrections and modifications based on our testing results is that the stairs that we included have to be fixed because they are too small. And in case of emergency, people need to leave and get down, go down the stairs. The stairs would not be efficient for that. We also want to rename some of our spaces because we realized that adding a library be would force students to be in a enclosed space. So we wanted to split it up into a first floor, which is a recreational room, and a second floor, which is the study room, which then can have spread out the space for students so COVID wouldn't be retracted as much. Also add more exits because one of our science classrooms did not include the right amount of exits that follow specifications. And lastly, our aesthetics slash layout, we have to rearrange some of the bathrooms because we got input from one of our mentors to change that because it's in front, it makes the layout ugly and it doesn't match the correct standards.
And so here's some of the additional testing data that we got from our mentors. We got this data from Ms. Bullwhite. She talked about how she was making a makerspace for the UNCC library, and she generally gave us this floor plan and traffic flow plan of the entire way a makerspace would look like. In total, this costed around like $500,000. So this is the amount of cost that we see that we will probably see if we're making a makerspace.
These are our citations, and thank you.